Hello team, this is Rene Alfonso. I'm going to be going over the finite state machine library that I created. The library follows the state design pattern. As you can see here, this is a library as a jar. It is used both on the back end and it will also be used on the mobile app. The idea of the library is that it makes it very easy for you to create a state machine. So I'm going to show you here an example on how to do this. First, we're going to create a package. And the first thing that we want to do is we want to create the owner of the state machine. So we have to make it implement iOwner interface. Then we just come here, implement the methods. So every owner has to have an FSM. And this will come in handy later on, we will see. In our case, the algorithm owner is going to take a questionnaire. Then we will pass it here. And then the moment the questionnaire gets passed in, we will initiate the state machine and then we will transition to a state. I will show you that in a second. First, we want to create the states. This is something that I like to do. I like to create the state. So state algorithm. I'm going to make it an interface. Now this interface is going to extend the iState interface from the library. And now the first thing we want to do is create an initial state. It's going to implement the iState algorithm, and this is going to make it enforce the three methods that it takes. So these methods are on enter. That is the first call that you get when you enter a state, and that's where you want to start doing the logic for that state. On exit is when you're leaving the state and you want to do some cleanup. You also have on event, and that's when you get an event from an outside source like another subsystem, and that tells you something happened outside of the state machine, and maybe you want to handle that event, you want to do some logic related to that, or transition to a new state. So the first thing that we can do here in the initial state is prepare the algorithm. Once the algorithm is prepared, we can transition to another state. I will show you that in a second. So let's create a state algorithm. And again, it's going to implement those methods. We go back to initial state, and we can say owner, get FSM, change state, and we just tell it, okay, now we want to go to the algorithm state. All the logic is handled by the library in the background, so you don't have to worry about what's happening with the transition and all of that. All you do is you worried about the work that you want to do per state. And this makes it very easy because every state handles only one thing. You make a state, and the state will do all the logic associated with that state and then transition out. That way you don't have a mess of spaghetti code and if statements all over the place. And this is actually one of the best things, because the moment that you get a defect, you can just see, okay, the defect is on the algorithm state. So you go directly to the algorithm state and you fix it there. Or the defect is on the completed state. Oh, okay, let's go to the completed state. We go there, we see what's going on, and then we fix it. You don't have to search a bunch of if statements and else statements to find out what's broken. So this is just an example on how to take advantage of this FSM reusable library. We will definitely have more states as we collect the data from the user and analyze that data from the user to come up with a meaningful result. This will definitely evolve as the project goes on, and we will notice the states that we need. Please don't hesitate to reach out if you have any questions about this. I know it may feel like a daunting task right now, but in reality this will make our lives very easy, and you will see that it's very easy to pick up and we barely have to do anything. All the hard work is already done by the library. We can just focus on making that algorithm solid and getting the right results for the questionnaire. Thank you, and again, don't hesitate to reach out if you have any questions.